This is the nature of the motion of a charged particle in a uniform electric field. It's as simple as that. You can be asked to find so many things. We can be asked to find the final velocity. We can be asked to find the final displacement. We can be asked to find so many things, or the velocity after a particular time t, and so on and so forth. So this is what we have from here. So let's assume that we are asked to find the angular displacement of that projectile, of that charged particle. What is the angular displacement or angular deflection? What is the angular deflection of the charged particle inside that uniform electric field? So in that my diagram again, what is the angular deflection? The angular deflection of the charged particle in this uniform electric field can simply be obtained because the charged particle moved like so. It is negative, so it moves up towards the positive. So what is the angular displacement? The angle made there is the angular displacement. The angle made there is the angular displacement. And how do we find the angular displacement from here? Of course, the final velocity horizontally did not change. It is still Vx, which is still the same thing as our initial velocity, while the final velocity vertically changed. So there is a velocity vertically, Vy, this is the final velocity vertically. There is a velocity horizontally, Vx, final velocity horizontally, and this is the angular displacement theta. So if I use my trig ratio here, this is Vy, this should also be Vy. So that means that I can see clearly here that tan theta, opposite adjacent, will be Vy upon Vx. Vy upon Vx. What is Vy? Final velocity vertically, which is Ayt. So that means this is simply Ayt upon Vx. What is our Vx? Vx is still V0. Now we can also extend this formula to, since I know that Ay, what's Ay? Ay is QE upon M. And T, what's our T from here? Sx over V0. Sx over V0. If I use Sx as X, that means I can say this is T is X over V0. Then divided by this V0 that is here. Ay is QE upon M. T is Sx over X over V0 over V0. V0 will come down. So we have QEX upon M V0 square. That's our tan theta. Then from here, what will be our theta? Our theta will finally become arctan of QEX upon M V0 square. That will give us the angular displacement or the angular deflection of that charged particle. So we have linear deflection and we have angular deflection of a charged particle inside a uniform electric field. So take note of this. We are going to solve problems now. Where is this guy?